So the goal of this video is to graph the function y equals 2 times sine of x plus 1. As a side note, you'll probably need a unit circle if you don't have that memorized right off the top of your head. Just for this tutorial, because we will be needing it, we'll be going over a little bit of the facts that come out of that unit circle. So just keep that in mind. If you don't have one handy, you might want to Google image, find one that's nice, or make one out of the tactile graph. So first, we're going to identify some steps. The first step is obviously going to be to construct our graph. The second step is to find a, b, c, d for an equation that you may or may not have seen. This is going to be this equation y equals a times sine of bx minus c plus d. And we'll talk a little bit about that in a little while. Then we're going to have to label our axis scale. We're also going to need to find some coordinates to plot, and then we're going to have to draw our wave. So starting with that step one, we're going to construct our graph. We're going to create two axes. Using the tactile graph, you're going to need 2 of the red axis sticks and 2 of the blue axis sticks. And then we're going to top each one with that white axis topper. And then we're going to center them all with the origin and insert our coordinate planes. For step 2, finding the ABCD that I mentioned from this y equals a times sine of bx minus c plus d. A is considered our amplitude. So looking at our problem, y equals 2 sine of x plus 1, the 2 is where that a comes in. That is how tall our graph is going to turn out to be. B is going to be, for our problem, this implicit 1 that lives within the sine of x term, because anything multiplied by 1 is going to turn out to be itself. So we can just write in a 1 for B. And we're going to use B to find our period. Our period defines how wide our wave turns out to be. And so we're going to use that period also to define our axis scale. Our x-axis heavily depends on that axis scale. And we want to make sure we use one that kind of makes sense with our period. We want to get at least 1 full period on the graph, but 2 is probably a better range, just so we really identify like what it looks like. And you can graph more, but then you might get like a really squished looking wave. Then we're going to find c. In our problem, there is no c. X is by itself inside of the sine of x function. So we'll just leave it at that. X or c equals 0. So there is no phase shift in our graph. It doesn't move over to the left or right at all. That horizontal shift is what you might have also heard it called. For d, we're identifying this as the vertical shift, how much our function jumps up. So you can think about it like a y-intercept, but only for this sine of x function. If this were a cosine of x, it would not be our y-intercept, but because sine of x naturally starts at 0 when x equals 0, we know that if we're going to add 1 to the 0, when x equals 0, y equals 1, that is our y-intercept for this function. So we're going to go ahead and start with step 3 now. We're going to start labeling our axis scale. As I mentioned just a moment ago, we want to define our period. We want to use that period to define our axis scale. So you can see I'm kind of choosing pi over 2 values because there's a unit of pi in my period, which is 2 pi. Again, that period is 2 pi over the absolute value of b. Since b is 1, then that just turns out to be 2 pi. And so I've incremented my axis by pi over 2 in every second notch. And that just makes it so I get a full wave. And I actually end up getting like a full 2 periods in my graph using the tactile graph. Using this handwritten graph, I didn't make my axes as long as the tactile graph, and so you'll see it's just not, it doesn't turn out as wide as the tactile graph turns out to be. And then starting with step 4, we're going to look for those coordinate points. As I mentioned, 0, 1 is our first coordinate point. We found that when we found D, because sine of x equals 0 when x equals 0, and so we're just relying on D to define our y-intercept. And then when x equals 2 pi, you can see me, I'm kind of drawing this circle, and that's because I'm in my head using the unit circle. When we're at pi over 2, we're at the top of the circle, and so when x equals pi over 2, the y term of that coordinate point is 1. We're up 1 on our unit circle. And so our pi over 2 ends up being, when x equals pi over 2, y equals 3, because we're going to take 2 times 1 plus 1. And then when x equals pi, we're going to go over half of a circle on that unit circle. And so we end up with 0 again for the y term of our coordinate. So when x equals pi, then sine of x equals 0, and timesing that by 2, we still get 0, and then we add 1 to it, and so we get when x equals pi, y equals 1. And we have another coordinate point, 3 pi over 2, so that is 3/4 of our circle. We're going all the way down to the bottom of that circle on the unit circle, and so y equals -1 at that point, so we end up with 2 times -1 plus 1, and we end up with -1. And that is where I made my mistake that I mentioned in that little short earlier. This is why I had to redo this tutorial, because I lost that -1 and I ended up making that term a 3, and my amplitude was way too short and my wave ended up all wrong. So here's me fixing it. And then I just chose one more point, which is the negative side of our graph. We have -pi/2. And so we can use the unit circle, and we can go, instead of going counterclockwise in our spin, we're actually going to go clockwise, and we're going to turn down to the bottom of our circle for pi/2. And that ends up being sine of -pi/2 is equal to -1, and then we times that by 2, and we get -2, and we add that to 1, and we get -1 again. So we've hit a full period by going all the way around, because we got -1 twice. So I'm going to go ahead and just plot those as the last step and draw the wave here. And that is our graph. We can draw arrows because we know it's going to go on forever. Thank you so much for watching this tutorial. If you liked it and you want to watch more, feel free to subscribe. I will be posting these tutorials at least once a week on this YouTube channel. Additionally, if you didn't catch everything I wrote down, or you didn't hear everything, then feel free to check out my website, tactiletutoring.com, where I post notes for this problem and all the other problems I've done, in case you just want something written down that you can follow along with. Also, if you like the tactile graph and you want one of your own, make sure to follow me on any of my socials, on my website, subscribe to my newsletter, because I will be talking about a Kickstarter campaign happening next spring. So be sure to follow along if you're interested in getting a tactile graph of your own, so that I can bring it to market.